Hello and welcome to this latest lesson in the OCR GCSE Computer Science series. Hopefully you have worked out from the infographic on your screen that this lesson is focusing around searching algorithms. How do we create algorithms that can search the entire internet in milliseconds and return back to us the answer that we wanted? As I said, this is lesson number 5 of Unit 2 Algorithms and Programming, and this one's called Standard Searching Algorithms. Where does that sit in terms of our bigger picture? Well, Unit 2 is made up of 5 key sections, and this is towards the end of 2.1 algorithms. So our first section on the left, and this is the 5th lesson out of 6. During this lesson, we're going to look at 2 different types of algorithms, a linear search and a binary search. We're going to look at how we can program those within Python, but you can use another high-level programming language if you like. And we're going to think about the advantages and disadvantages of each one. So pause the video at this point and have a go at the 3 questions on your screen. What problems might Google have faced over the last decade? How has what Google needs to do changed? And what problems might Google face moving forward over the next decade or so? Pause the video at this point, have a think around those questions before we move on. So for the GCSE, you need to know 2 standard searching algorithms. These are 2 algorithms that are used across many different web applications, many different mobile applications, loads of computer games, and there are 2 key ones that we need to know. The first one is called a linear search. In a linear search, we search through an entire list, one element at a time, until we find the result. So a linear search really is our most basic and most simple type of algorithm. Let's imagine I've got 10 numbers in a row. Well, I check, is it the first one I'm looking for? No. Okay, is it the second one? Is it the third one? Is it the fourth one? I just go through the entire list until I find the thing I'm looking for. The example on the board is looking for the number 25. It checks position 0, which is the number 3, then position 1, which is the number 15, and it keeps going until it finds the result, or in this case, gets to the end and doesn't find it. Quickly pause and have a think. What are the good things about this? What are the bad things around this? So, first good thing, a linear search is very, very simple to program. It's quite difficult to get wrong, and it would be fairly rare for a programmer to leave a bug in a linear search. It's kind of either going to work or it's not. A linear search provides fairly decent performance over small and medium-sized lists. And a linear search does not require the list to be ordered in any way. It doesn't need to be in numeric or alphabetical order. It will always find the answer if the answer is in the list somewhere, and it doesn't matter how the list is ordered. The disadvantage is that with most simple things, it's fairly inefficient. It's going to be very, very slow on big lists. If we've got 2.4 million records, well, there's going to be 2.4 million comparisons in a linear search. It really is going to take a very long time to find the correct answer. Okay, pause the video at this point. I'd like you to create a list of 10 items in Python. I'd then like you to use a for loop and an if statement to try and create yourself a basic linear search. Now, if you haven't started looking at Python yet or a high-level programming language yet, do this in pseudocode or OCR exam reference language. That video is available on YouTube if you haven't looked at that one yet. So pause the video at this point, ideally in Python, but if not, in OCR exam reference language. Pause the video at this point, the answer is coming up. So here is our answer. The first line defines the list. We've got the words hello, goodbye, how, are, and you, because I'm not feeling very creative. Print, enter your search term, search equals input. Those first 3 lines are fairly simple. Define the list and ask the person which they'd like to look for. The remaining lines then loop through the list, so we're using a for loop, a count-controlled iteration loop to loop through our entire list, and then an if statement to say, is each word the correct one? Is each word the one we're looking for? If yes, print out where it exists. If you've done that in OCR exam reference language, it clearly won't be exactly the same, but you've hopefully got something fairly close. In the exam, you should be able to identify a linear search through its pseudocode and possibly make corrections to the code that you are given. Our second searching algorithm is called a binary search. Now, a binary search checks through the algorithm by constantly splitting the array in half and checking whether the midpoint is the value. Now that's going to make a lot more sense on the next slide, but a binary search searches through a sorted array by constantly splitting the array in half and checking whether the value is higher or lower. So let's pretend I've asked you to think of a number between 0 and 100, and then I'm going to make a guess what number you're thinking of, and you're going to tell me higher or lower. What's my most efficient first guess? Well, I should guess 50. 50 is the midpoint, so I'm guaranteeing that I'm going to remove 50% of the numbers with my first guess. You tell me it's lower, so what's my next guess? Well, I should guess 25, because 25 is the new midpoint. That's exactly how a binary search works. Looking at the example on the board, we're looking for the number 5. And I've got an ordered list of numbers 1, 2, 3, 5, 8, 13, 21 and 34. I select the first midpoint. Now, a list doesn't always have a midpoint. The midpoint here is some white blank space. So I round up. Just always round up. Okay, so I compare my number to the number 8. Well, it's lower than the number 8. So I remove the numbers 8, 13, 21 and 34. I'm left with a new list, 1, 2, 3 and 5. I compare to the new midpoint. Well, again, it's some white space, so I move up to the number 3. I continue that process until I find the number that I'm looking for. I continually half the list, check against the midpoint, and check is it higher or lower. Now, there is a star galaxy that lists 2.5 million stars that are in our galaxy. Now, with a linear search, I'd need 2.5 million comparisons. With a binary search, the absolute worst case scenario is that I'm going to need to check 22 comparisons. 22 versus 2.5 million. Clearly, a binary search is much more efficient in terms of the way it finds that data. So a binary search is much more efficient than a linear search. It's going to be much quicker on big lists. The downsides, well, that means it's harder to implement, harder to program, and it relies on the array or the list being ordered in the first place. If you try and run a binary search on a list that isn't ordered, it's not going to work. Nearly always, a question related to this in the exam gives you a list and says, why would a binary search not work? The answer's always going to be because the list isn't in order. If you blank in the exam, make a guess at that. So I'd like you to create a new program in Python or OCR exam reference language to implement a binary search. Now, a binary search is harder, so I've got a flow diagram on the next slide that I'm going to show you that you can hopefully use to help you create either your pseudocode or your Python code. Here is the flow diagram. Have a read through this one. Pause the video at this point. This one is tough, but look through the flow diagram and see if you can program something like that to create you a basic binary search. Pause the video at this point. The answer's coming up. So here is our binary search. We get the first position and the last position. That is the first position where the answer might exist and the last position where the answer might exist. Within my while loop, I work out the midpoint. And I then repeat that over and over again until I find the word that I'm looking for. Hopefully you've created something like that. Again, you won't need to program that in the exam, but you might be expected to identify what searching algorithm that one is if you were given it, or to look for some errors in some code that you were given. If ever you see an algorithm working out the midpoint, mid equals first position plus last position divided by 2, make a guess that it's a binary search if you really are struggling to identify it. Okay, a final activity now. Take a look at the past exam question from one of the OCR specimen papers. Show the stages of a binary search to find the word zebra when applied to this list. It wants you to rewrite out the list at every comparison or every time the list is going to change. Pause the video at this point, write out what would happen to find the word zebra, showing these stages. So for 4 marks, here is the mark scheme. You should have compared zebra to orange. You should have in some way shown that the word we were looking for is greater than orange, probably by discarding the left-hand side of the list, 2 marks. You then need at least one more comparison, depending on whether you round up or down, and then you should correctly identify zebra using the methodology above. E.g., compare zebra to orange, greater split right. Compare to wind, greater split right, compare to zebra. If you'd written something like the example bit at the bottom, that would give you your 4 marks. So what do we need to know on one slide? We need to know what a linear search is, what a binary search is. We need to know their advantages and disadvantages of each one. It's useful to know how to program them, but that bit isn't the end of the world. You might be given the pseudocode, and if you know how to program them, that might help, but really the advantages and disadvantages are the key parts, along with being able to show the stages as per the example on the previous slide. As always, thank you for watching. If you have any questions, please either post those onto Google Classroom or into the comments section below. Thank you very much.